Okay, so how do we find, using derivatives, whether a curve is increasing or decreasing? Well, f of x will increase on an interval when f prime of x is positive on that interval. So let's think about what that means. Okay, if I come back to this graph here and I look at the f prime of x, okay, we know that it's increasing from here to here, right? Well, if I take my tangent, because that's what the tangent is, it's the derivative at this point, okay, that would be the tangent at that point, and I take the tangent at that point, and I take the tangent at that point, okay, at that point, and maybe at that point as well, you can see that the tangent lines are all positive, okay? The slopes of those, the slopes of those lines are all positive. And that means because the slope is the same as the derivative, that the derivatives are all positive on this interval. So what that's saying is f of x, okay, f of x is going to be positive here. F of x is positive on this interval. On this interval, you would expect to see, well, if I draw a line this way and draw a line down this way, okay, you can see that the slope is going down. Okay. Okay, that's not a very good line, but you get the idea. This would be f prime of x would become then negative, right, on this interval. And likewise, on this interval, you'd expect to see f prime of x be positive. Okay. So using the derivatives, it's actually very easy to find when a graph is increasing or decreasing. But obviously, in order to test this, I'm going to need to know this point and this point, right? Those are called critical values, and we'll talk about those more in a little bit. But those are local maxima, local minima, and you can find those by searching for when the derivative is 0, right? The derivative is 0 at this point because the tangent line is horizontal. Okay, so the tangent line being horizontal means that the derivative is going to be 0 because the slope is 0, right? Okay, so let's do some examples here. Let's go ahead and we'll be using a tool called sign diagrams, which you may have seen before, and we'll use those to kind of help us determine whether a function is increasing or decreasing. Okay, first of all, let's start by taking the derivative of this. What is the derivative? What's f prime of x? Well, that would be, since that's x squared, that would be 2x. So that's my derivative function. Okay, I'm going to go ahead and create something called a sign diagram, and this is for the prime function, okay, the derivative function. What is 2x? When is 2x equal to 0? Okay, when is this equal to 0? At 0, right? At 0, you would expect to see 2x go to 0. So now what I do on the sign diagram now, this is called a critical value. This is the value that, this is like a local minimum, and I'm going to see what's happening on either side of that critical value. Okay, so I'm gonna look at, well, this is a graph. Normally I'd assume we don't have these, but I'll just leave this here. If I plug in a number that's negative, okay, the output of my derivative is also going to be negative. So that's also going to be negative. If I put for instance, 1 in here, I'd get 2 out, so that's positive. So you can see here I have a negative slope down here. I have negative and I have positive up here, so that means that this would be decreasing on this side and increasing on this side. Okay, so we have just found the intervals of decrease. We could say that f of x is decreasing, okay, I guess you could say decreasing when x is less than or equal to 0, or increasing when x is greater than or equal to 0. Okay, and we will actually use, I probably should have done this in the previous video, but we will go ahead and use the equal sign on this to indicate the interval. Okay, if I was to use interval notation, I would probably use negative infinity to 0 including. Okay, we're not going to get too technical about this, but you can choose to write it like this for now. Okay, and this would be from 0 to infinity. That should be a square bracket. Okay. All right, let's try this one. Same thing. We're going to do the find the derivative. F prime of x is equal to minus 2x. And so if I go ahead and draw the sign diagram, I would expect to see this go to 0 at the point 0. And so I have two intervals to test since there's only one critical value. Okay, here there's one critical value, and that's called the maximum here in this case and the minimum in this case. So now we test this. We just create a test point, put -1 in. If I put -1 in, I get a positive. If I put a positive number in, I get a negative out. So I have increasing on this side and decreasing on this side. So you can expect, we could say that the it's increasing on the interval from negative infinity to 0 and decreasing on the interval from 0 to infinity. All right. Same thing with this one. F prime of x would be 3x squared. Okay. And the sign diagram, if I were to draw it, since this is equal to 0 when at 0, I would have the derivative on this side. If I put it, let's say -1, because it's squaring, that would be positive. If I put a positive 1 in here, that becomes positive. So we have a plus here and a plus here, so it's increasing on this side and increasing on this side. Okay, so now this is interesting. Okay, it's increasing for all values of x. We're going to say it's increasing at all values of x. Okay, even though you would think that right here it's not increasing, we are just going to say that it's increasing. Okay, because that's something called a point of inflection, which we'll get to later. But we don't consider increasing or decreasing for points. We only consider increasing and decreasing for intervals. Okay, and since we're looking at this interval and this interval, we can include that endpoint. But we'll say from negative infinity, it's increasing from minus infinity to infinity. Okay, and so since it's increasing on all values of x, we actually say that is monotonic. Okay, we say it's a monotonic increasing function. Okay, we say it's a monotonic increasing function. Monotonic increasing or monotone increasing. Okay, monotone means not changing, right? Or one tone, so it's not changing. So you can remember that. And likewise, if it was to look like this, where it was constantly decreasing. Okay, if it was constantly decreasing like that, that would be called monotone decreasing. Okay, sorry, there's a little bit of a lag here on the computer. So monotone decreasing. All right. Okay, let's try this one. What's f prime of x going to be? That would be equal to 3x squared, right? Minus 3. Okay, so 3x squared minus 3 would be my derivative function. What would be the zeros of this? Well, to find the zeros, I actually have to factor this. Okay, if I factor it, I get 3 times x squared minus 1. And now I get 3 times x minus 1 and x plus 1. Okay, so I have two zeros. I have two places where we have critical values, where f prime of x is 0. Okay, so we have two little critical points, and that's at x equals 1 and x equals minus 1. Those are the solutions to this. I guess that should be a 0. Okay, so now I have -1 here and 1 here. Those are the 2 points that I'm interested in. I have 3 intervals to test. Okay, if I put in a negative, let's put a -2 in here. If I put a -2 in here, I would get a positive number, positive 4 minus 1, so it's increasing, times 3. So that would be increasing. If I put a 0 in here, I get 3 times negative 1, so that would be negative. If I put a 2, I get the same thing, right? I'd still get an increasing number. So you can see here that this would be a increasing, decreasing, and increasing function on these intervals. All right. And so you could say increasing, it is going from minus infinity to negative 1, okay, and from 1 to infinity, and it's decreasing from negative 1 to 1. Okay? All right.